Hello and welcome back. In today's class, we'll be looking at mastering complex join, where we'll look at join types like the inner, the left, the right, and the full outer join. We'll also look at subqueries. We'll also be looking at the industrial applications of all of these. We'll then next look at the set operations, where we'll be looking at operators like the union, the except, and the intersect. We'll also look at the industrial applications of all of these. We'll lastly close with Windows functions. We'll be looking at functions like the row number functions, the rank, the league, and the lag. We'll be looking at the industrial applications of all of these. In our previous video, we started by looking at introduction to SQL and SQL syntax, where we'll look at command types. We'll also look at the SQL commands like the select, the group by, and the where class. We'll look at all the industrial applications of all of these. If you haven't watched our previous video, I encourage you to do that because this will give you a clear context of what we'll be doing today. Because in today's class, we'll be building on what we've started already. So sit back and relax.
By the end of this class, you should be able to gain a comprehensive set of skills and knowledge to supercharge your data analysis capabilities. We will start by mastering the inner, the outer, the left, the right, and the full outer join as powerful tools for combining and analyzing data from multiple tables. We will now see how these operations can be applied to solve real business problems such as generating reports and tracking resources effectively. Next, we will learn how to write and use the next subqueries for dynamic filtering and calculations. These techniques will enable you to solve advanced data analysis challenges like identifying outliers, comparing key matrices, or aggregating data in hierarchical structures. Next, we will see how to use the union, the intersect, and the except to combine, compare, and exclude datasets. These tools will help you to perform critical tasks like merging data from different sources, analyzing overlaps, and identifying unique data points. And finally, we'll dive into advanced row level analysis by applying the functions like the row number, the rank, the lead, and the lag. With this, you'll be able to analyze trends, rank employees or products, and identify gaps or changes in data sets over time. Get ready to apply these powerful tools and techniques to unlock deeper insights and make smarter data-driven decisions. Let's get started. Now, we'll start by looking at complex join and then we'll close with subqueries. What are joins? Joins are powerful tool in SQL used to combine rows from two or more tables based on related columns. Advanced joins types such as the inner, the left, the right, and the full outer joins allow for more sophisticated data retrieval. These techniques enable deep analysis by seamlessly merging data sets and uncovering meaningful relationships. Subqueries, on the other hand, are queries nested within another query. These are often referred to as the inner queries, while the enclosing query is called the outer query. Subqueries are particularly useful when retrieving data from multiple tables, while offering a flexible and dynamic approach to complex queries. Explore these tools to unlock the full potentials of your data. Now, this will now lead us to look at one of the types of join, which is the inner join. The inner join let us to combine rows with matching values in both table. So we have the syntax for the inner join as select. You specify the columns that you want, and then from you indicate the table that you want, and then inner join you are joining the second table, and then on you specify the relationship that exists between the two tables. That's the column that those two columns that forms the relationship. So we have table 1 dot column name and table 2 dot column name. So we have an image illustration to show us how we can use the inner join. So we have two tables, table A and table B. Table A has student ID and name. Table B has student ID and department. So when we use the inner join, we have the resulting as this particular table below, which we have student ID 1004, which has a name of D and a department of mathematics. This is the only record that exists between the two tables. So this is how we use the inner join to be able to retrieve the matching record. So we have an example for us to illustrate a real business scenario. We are to find employees with their department names. So in our previous class, we've seen how to create database, which we did, and we create two tables, which we have the employees and the department. So if you haven't watched our previous class, I encourage you to do that so that you should have a better and clearer context. So let's go back to our ID and so that we can be able to implement the inner join. So let me open my ID, which back to my ID. So I've inserted two records, one in my department record and the other one in my department table, sorry, and the other one in my employees table. So you can pause this video and go ahead to also add these two records so that we can be on the same page. Next is for me now to write my comment in order to get our employees from our for us to solve our business, our real world business challenge. So let me write my comment. So in order for me to find my employees with their department names, I'm going to get my columns. So first column that I will get is the employee name, which is coming from our employees table. Next, I'll get the department name, which is coming from my department table. Next, we will indicate the tables that we want. So from employees, which we have E as our aliasing, and then I'll use the inner join now. The inner join is the keyword that we use to join two tables from the matching record. Then my department, I will indicate the department D, which is our aliasing, and then I'll specify the relationship. So just the way we see from the syntax, you specify the relationship. So we have E dot department ID equals to D dot department ID. So this particular query now is going to extract matching record that exists between the two tables. So let's run this so that we can see the result. So let me highlight this and run. So you can see our table of where we have all the matching records. So we have John Oga, who belongs to the logistics department. We have Alice Udo, who exists in the IT department. We have Agapisa. So basically, we have 6 rows that exist in both table. Now, this leads us to look at the other type of join that we have, which is the left join. The left join, on the other hand, allows us to return rows from the left table and then matching records from the right table. If no match record is found, null is returned. So the syntax for the left join, we have select, you specify the columns that you want, and then from you indicate that the table that you want to get your data from, and then left join your table 2. Then you will now use the relationship that exists between them. So we have table 1 dot column name equals to table 2 dot column name. So this now allows us to specify the columns that forms the relationship. So we have an image illustration to represent the left join. So we have student ID, student ID and name, which is in our table A. We have student ID and department, which is in our table B. Now, when we left join these two tables, we have the results as student ID 1001, which is coming from table A. We have the name as A and the department is null. Why is returning the null is because this doesn't exist in table B. So that is why we can see the null. And then we have student ID 1002, which is also coming from table A and has the name as B, and then the department is null also. This doesn't also belong to the right to the table B. We also have student ID 1003, which is C, which is doesn't have a department also, only student zero, there's only student ID 1004, which has D. It's coming from the mathematics department. So now this is the only match record that is coming from the right table. Wherever there is not those records are not there, we have them return as null. So we have an example also. The example here, we are to list all employees and their department, some depart even if some are not assigned. So let me go back to my ID so that will also show that in action. So back to my ID. Let me close this. So next is for me to comment my result. So I've written down my comment. Next is for me to get my columns that I want. So firstly, we need to get our employee name. So we select and then we retrieve the employee name from our employee table. Next is for us to also get the department ID, which is also coming from our employee table. And then lastly, we'll get the last column that we're getting is the department name, which is coming from our department table. Then next, we specify the employees table, employees, and then we put in our aliasing, which is E. Next, we'll now specify our left join departments. We specify department with our aliasing D, and then we'll now specify the relationship that exists between the two of them, which we have E dot department ID equals to D dot department ID. So this will now allows us to left join our we'll bring our records from the left table and then we'll join with the matching records in our right table. So let's run this so that we can see how the result plays out in action. So let me highlight this and then run this. So you can see we have all our records that we bring all our left table, which is our employee name, and then we also brought our matching records from our right table. Now we have only John Ugo, who doesn't have any records in our right table. He doesn't have department ID, he doesn't have department name. So all the record that doesn't exist in our left table, we can see it has returned it as null because they don't belong to our left table. Next, this will now lead us to look at our right join. The right join is the opposite of the left join. The right join returns all rows from the right table and any matching record from the left table. This allows you to include all data from the right table even if there are no corresponding matches in the left table. It's a useful tool when you want to focus on the right table as the primary source of data while still incorporating any related information from the left table. So we have the syntax for that as select. You specify the columns that you want. From you indicate the table, right join your table 2, and then on you specify the relationship that exists between those two tables. And then so we have table 1 dot column name equals to table 2 dot column name. So these are the columns that form the relationship between the two tables. Next, we have an image illustration to show how the right join works. So we have table A, which has student ID and name, and we have table B, which also have student ID and department. And then we have, when we right join our two tables, we have the resulting table as table 1 ID, student ID 1004, which has a name of D, belongs to the mathematics department. So this now is coming from our right table. That's why we can see, and it also belongs to our left table. So that's why we can see the name. Now we have student 1005, which is also coming from our right table, which doesn't have a name because it doesn't belong to our table A. Because it's our table A now, that's our left table that houses the name. So where the name doesn't belong, that's why we can see the null there, and then it belongs to the mathematics department. So also we have student ID 1006, we have also 1007. All these two doesn't have student name because they don't belong to our left, they don't belong to our right table, to our left table, sorry. We don't have the name in our left table. Then we also have student 1008, which is coming from our computer science department. Also doesn't have a name in our left table. So all the places that you see the null are coming from our left table because those results do not belong to our left table. So we have an example to illustrate how this plays out in a real world scenario. List all departments and their employees even if some departments have no employees. So let's look at this and see how this plays out in our IDE. So let me go back to my ID. Back to my ID. Let me close this query so that I can be able to comment my what we want to achieve. Let me go ahead and comment that. So we are to list all the departments and their employees. So even if some departments have no employees. So let me select the columns that we want to see. So basically, we want to get our department name, which is coming from our department table. Then next, we will get the name of the employee, which is coming from our employees table. We'll specify our tables. So we have employees E as our aliasing. Then we'll indicate, we'll write join the department table, which we have aliasing as D. Now we'll specify the relationship between the two tables, which we have D dot department ID equals to E dot department ID. So this now will return all our right table, including with the matching result from our left table. So let's run this so that we can see how which we can see our departments with their employees. So let me highlight this and do that. Right, I highlight this. Let's run. So we can see all our department with their employees. So we have the HR have Agape Sam. We have IT has Ali Zudo. IT also has John Joseph. Finance has John Abi. Lastly, to our procurement. So we have one other record which does not belong to our right table, and then it also do not belong to our left table. So that's why we can see the null here. We don't have the employee name, neither do we have the department name. So this is how we use the right join in order for us to achieve that. This will now lead us to look at the next type of join, which we have the full outer join. Let's explore the full outer join. The full outer join combines rows from both tables. It displays matching rows where there is a connection between the two tables, as well as unmatched rows from each table. For any unmatched rows, null values will be used to fill in the missing columns from the other table. This type of join is perfect when you want to analyze data comprehensively, ensuring no information is left out from either table. So the syntax for it, we have select, you specify the columns that you want, from you indicate the table that you want, full outer join table 2, and then you specify the relationship, which is table 1 dot column name equals to table 2 dot column name. We have an image to illustrate our example also. We have table A, which has 1, 2, 3, 4. We have table B, which has 3, 4, 5, and 6. And then when we use the full outer join, it gives us this resulting table, which we have 1 is coming from our table A, 2 is also coming from our table A, 3 is also coming from our table A, 4 is coming from our table A. And then we also have 3 coming from table B, We also have 4 coming from table B. So it only picks one of the 3 and 4 for us to have it in our resulting table. Next, we have 5, which is coming from table B. We have 6, which is coming from table B. So basically, this is how we use the full outer join to implement this. We can see the resulting table that it has given us. We have an example to illustrate this in real world scenario. We are to combine employees and their departments showing all records from both tables. So let me go back to my ID. Next is for me to comment on what we want to achieve here. Let me go ahead and comment. Before we go ahead to select our columns that we want to retrieve our data, I need to state it here. The MySQL workbench don't really support the direct implementation of the full outer join and clause. So the way we are going to do it, we're going to see how we can do it using another different means. But if you are using an RDBMS, that's a relational database management system that supports the full outer join implementation directly, you can go ahead and use the full outer join clause. So, but for us, we'll see how we can do that. So let's retrieve our columns. So we want, first of all, we want to retrieve our employee name, which is e.name. This is coming from our employees table. Next, we also want to get the department name. So d.department name, which is coming from our department table. Next is for us to get our table, our employees, and then for us to do that, we'll first of all bring our left table. So let's left join our department D, and then we'll specify the relationship on e dot department id equals to d dot department id. So basically what we intend to do is that is for us to bring our left table, and then with the matching record from our right table, and then we will use the union to also bring the right table, then with a matching record from the left table. With that, we can be able to achieve the full outer join. So we'll also bring the name and the department from the department table. Next, we will specify the tables, employees, E, and then we'll right join this time around. This time around, we're bringing our right table departments. Then we'll specify the relationship that exists between the two tables. So e dot department id equals to d dot department id. So basically, this will be able to help us to achieve the full outer join, whereby we bring the left table with the matching records from the right table. We also bring the right table with the matching record of the left table. So with this, we can bring all the data from our two tables, even though if they are on match records, I know will be assigned to them. So let's run this so that we can see our resulting output. So let me highlight this and run. So we can see our resulting output. We have the names of our employees. We have John Oga, which belongs to the logistics department. We have Alice Udo, who also belongs to the IT department. And also we have John Ugo, who doesn't have a department name. That's why we can see the null. And then we also have another null record here. This doesn't have either the department name nor the employee name. So basically, this is how we implement the full outer join. This will now lead us to look at the next type of subqueries. So for subquery is a query nested inside another query. A subquery allows you to use the result of one query as input for another query. This is particularly useful when you want to filter data or apply advanced logic that can't be handled in a single query. Subqueries helps you to retrieve data based on more complex conditions or calculations, making them essential for performing sophisticated data analysis. We have our image illustration to also explain for us how the subquery works. So we have we want to get our order ID here, then we want to get our order date column. We also want to get our customer ID from our orders table. Now, this is our outer query, and then where we want to give it a condition where the customer ID in, we want to also retrieve the customer ID, and then we want to get the from our customers table, I want to get where the city is New York. So this forms our subquery, and then we are ordering them by the order date in a descending order. So we can see this is how we can play around with our subqueries. Next, we have a real world example. We are to find employees earning more than the average salary in their department. So let me go back to my IDE so that we can be able to do that. Back to my IDE. Now let me close this result panel. So let me go ahead and comment this. For us to get our employees who are earning more than the average salary in their department, let's get the employee name, which is coming from our employee table E dot employee name. We have, then let's also get the salary. Now it's coming from our employees table, employees E. Next, we will use the where class to give a condition. We have seen in our previous class that we use the where class anytime we want to get our data based on condition, a predefined condition. So we want to get our salary where it's greater than, and then we will now open a bracket for us to get our subquery. So we want to get the average salary, so we'll select and then we'll say average salary avg as for average, that's the keyword, and then we specify the column, that's salary, and then we will specify the table, which is employees. Next is for us to specify the department, sorry, where I didn't specify my conditions, where department ID equals to d dot department e dot, sorry, where it's department ID is equals to e dot department ID. So this will be able to retrieve the average salary of our employees where they are earning above their average salary. So let me shift this so that we can run this and see the resulting result. So by the time I run this, we can see only John Joseph earns above the average salary in his department, which is 300,000. So basically, this is how we use the the subquery. So we have this is forms as our outer query, and then this is our inner query. So this now will lead us to look at set operations. So we'll be looking at some operators in the set operation. Well, let's start with the first one, which is the union. The union operator is helps us to combine data from two or more select queries into a single unified result. One important feature of the union operator is that it automatically removes any duplicate from the combined result, ensuring that each row appears only once. That's one of the key important features of the union operator. So we have the syntax for the union operator, where we have select, you specify the columns that you want to retrieve your data from, you specify the table that you want, union, use the keyword union, and then you will now specify the second table that you want to get your data. You get specify the columns, and then you specify the table from the table 2. That's what we have. So we have an image to illustrate the union operator also. We have two tables. We have table 1, which contain employee ID, employee name, and age. Then we also have another table. We have manager ID, name, and age. So using our union to get the columns that we want. So we want to get the age from the employee table, and we also want to get the age from the manager's table. So now we use the union operator to get a single table result over here, where we have 21. 21 is coming from the table B, and then we also have 23. 23 exists in both table A and B. Like we said, the union operator combines the resulting from the two tables, and then it excludes any duplicate. It removes any duplicate. That's why we can only see 23 over there. Next we have 30. 30 is coming from table A. Next we have 34. 34 is coming from the two tables. Next we have 35. 35 is also coming from the two tables. And lastly we have 43. 43 is coming from one table. Sorry, 35 comes from the only the first table, but it appears twice. So we lastly have the 43. 43 which comes from the last table. So you can see all where we have duplicates, the union operator was able to exclude it for us. Next, we have an example to also illustrate that we should list all unique department IDs in our employees table. So let's go back to our IDE, back to our IDE, then let's write our comment. For us to list all the IDs in our all the department IDs in our employees table, let's first of all get our department ID, department ID, department ID, which is coming from our department. So let's alias it to let's say department men IDs. Let me use the capital letter here, IDs, and then let's specify from the table it's coming from our department table. Next is for us to use the union keyword, and then we'll also get the names of those employees, those unique IDs, the names in the employees table. So let's select and get the names of our employee. So let's use the name, and then let's alias it as employee name, employee name also, and then let's get them from our employees table. Let me use it as capital from employees. Now with this, we can be able to list all the unique IDs in our department in our employees table. Let me highlight this so that we can see all the unique IDs that exist in our employees table. So let me run this. We have 102, we have 101, we have 102. Normally we have 102, but you can see it's only one. This is the work of the union operator. We also have 103, we also have 104, we have 105, and it also uniquely lists all our employees names, and it's concatenate the two because we use the union to form all of this. So you can see how we use the union table to do that. This will now take us to look at the next operator that we'll be looking, which is the intersect. The intersect operator gets records that are identically or shared between the result of set of two or more tables. So we have the syntax for it as select. You specify the columns that you want. From, you indicate the table that you want, and then you use the keyword intersect. Then you select the second table that you want. That's the columns of the second table from the second table itself. We have an image to illustrate how the intersect operator works. We have table 1 as has an IDs of 1, 2, 3, and 4. Then we also have table 2, which has IDs of 3, 4, 5, and 6. Now, when we intersect with the keyword intersect, we have the resulting table as showing ID 3 and 4. Now we have 3 exists in table 1, 3 also exists in table 2, 4 exists in table 1, 4 also exists in table 2. This is how we use the intersect in order for us to only get identical or shared data between our tables. We have an example to illustrate in real business scenario. We are to list the department names not yet associated with employees. Let me go back to my ID so that we can be able to implement that. Back to my ID. Let me close this resulting panel. Next is for me to write my comment. We are to list the department names not associated with employees. Firstly, I need to say this. The INTERSECT does not directly being implemented by MySQL Workbench, but in case you are working with an RDBMS, that's a relational database management system that implements the INTERSECT directly, you can go ahead and do that. But for us, we'll see another a means of us to achieve that. So let's return our columns that we want. Firstly, we want to get our department name. So d dot department name, which is coming from our departments table, and we have our aliasing as d. Next is for us to get our table, that's departments. And then we specify our aliasing, and then next is for us to use a where clause. This will help us to give the condition not exist. We've already established that we use the where clause in using for predefined conditions. So let's open our bracket. Let me move this and write a subquery is inside our bracket. So let's return the exact match of our record. Then from our employees table, E, then we'll also specify the condition where E dot department ID equals to D dot department ID. Then let's close our bracket, and then let's also terminate our sentence. So with this, we were able to achieve how to list all the names not associated with employees. Doing this is the same way as you if your system your RDBMS implements the direct intersect, we will arrive at the same result. So let's run this so that we can see this. We highlight all, and then let's run. So we are able to list all department name not associated with our employees. In our own result, we have none because all our employees have department. That's why we can't see any result. If we had any employee that doesn't have any department, we could have seen it. But in our own case, because we didn't have, that is why we couldn't find that. So this now takes us to look at our next operator, which is the except. The except operator retrieves all unique records from the left operand, that is the query, and including excluding those that are also part of the right operand. The result set it essentially returns the rows from the first query that do not appear in the second query, ensuring no duplicates are included from the right table. So for the syntax of the except, we have select, you specify the columns from the table that you want, and then you use the except keyword, and then you also select the second columns from the second table that you want, and you indicate the table that you want. From our own is table 2. So we have an image illustration for us to explain more further how the except works. So we have table A, which has ID and value, and we have the right table, we have the left table, and we have the right table. The left table has ID column and val column. So also the right table. We have ID 1, which has value n1. We have ID 1 again, which has value n1. We also have value 3, which has ID 3, which has value L3. We also have ID 4, which has value L4. Now we have our right table where we have ID 1 has a value N1, ID 4 has value R2, ID5 has value R3 and ID6 has value R4. When we use the except, we get ID3 and 4. Now, how do we arrive at ID3 and 4? We set the except picks the left operand. So you can see where there are duplicate, where it exists in the right table, it exclude that. So you can see ID1 we also have in our left table, we have ID1 also in our right table. That is why we excluded the first row. We also have ID1 in the second row, which also exists in right table. That is why we also ignore that. Then we have ID3 and 4. Now these do not exist in our right table. That is where we are able to return it. So basically this is how the Excel table works. Now this will now take us to look at Windows functions. So in our Windows function, we'll be looking at some of the functions. The first function that we'll be looking at is the row number function. What is the row number function? The row number is a ranking function that assigns each row in a partition in a unique sequential rank number. If two values are identical within the same partition, the SQL will assign then a different rank numbers based on the order in which they are displayed. The syntax for this function is as follows. So let's look at the syntax for it. We have select, you specify row number, and then over, and then you open your bracket, and then you partition by, you specify the column to which you want to partition, and then you also order by the column that you want to order, and then you can alias it to different a different name. In our own case, we have row number, and then you specify the table that you want to. Now let's explain this with an image illustration. We have select, and then we want to get our employment ID, employee ID, and we want to get our employee salary, and then we also want to get our employee department. Then we use the row number function, and then we partition by the department and we order it by the employee ID. Now we alias it to sequential number from, and then we indicate the table. So by the time we run this, we have this resulting table. We have our employee ID, which we select the column. We have employee salary, which we also select the column. We have employee department, which we select the column, and then the now created column that we did, which is the sequential number. Now you can see that employment ID 108, employee ID 108, 109, and 110, all of them belong to the HR department. And then we can see that it gives them a different sequential number because all of them exist in the same department. So also our logistics, all of them, it gives them different sequential number. The third one is also production, it also assigns them a different sequential number. And then lastly, we have the sales department, which also assign them a different sequential number. So that is how the row number function works. It assigns group of data with different sequential number. So let's explain this our syntax here. We have the over. The over, this is a clause that specifies the windows or set of windows that the window functions operate with. Then next we have the partition by. The partition by is an optional clause in the row number function. It is a clause that divides the result set into partitions. So as we can see in our image illustration, whereby each unit was grouped into different partitions. We have the HR, the sales, the productions, all were grouped into different partitions. So that is where the partition by does. Then the next we have the order by. Within each partition, this clause allows us to order the rows in the result set. Because the row number function is order dependent, it is a necessary clause. Now also, we've seen how it has ordered all our records in our image illustration example. So we have also an example to illustrate how the row number function works in a real business world scenario. So we are to number employees by department. So let's go back to our ID again so that we can be able to number our employees. So let me close this my result panel. So for us to get the number of employees by department, let's retrieve our data from our columns. So we want to get the name of our employee. Next is for us to get the department ID. We want to get the department underscore ID. Next is for us to use the row number function. So row underscore number. Then we open and close bracket. We use the over keyword. Then we open bracket. Then we want to partition. We specify the column to which we want to partition our data. Partition by. So we want to partition it by the department ID. And then we want to also order it by our employee name. So we close our bracket and then we want to assign this to as our row underscore number. Next is for us to specify the table to which our data is coming from. So it's coming from our employees E. So with this, we can be able to number of our employees by department. So let's highlight this and run. So we can So we can see our resulting set. We have John Ugo, who doesn't have a department ID. It has a row number of 1. We have Agape Sam, which belongs to the 101 ID department, has a row number of 1 because he's the only person in that department. We have Alice Udo and John Joseph. They belong to the same department ID 102. Now it assigned a different sequence, row number sequence for them. The first person is assigned 1, while John Joseph is assigned 2. While the rest of our employees, all of them are 1 1 in their various departments. That's why we can be able to see only 1 is being attached to it. So this is how we use the row number function. This will now lead us to look at the rank function. The rank function is used to assign a rank to each row within a partition of a result set. Unlike other ranking functions, the rank functions introduce a gap in the ranking sequence when there are duplicate values. This behavior is particularly useful in scenarios where you need to differentiate between rows that have the same value but still maintain the integrity of the ranking sequence. In other words, when 2 or more rows share the same value and thus receive the same rank, the next rank in the sequence will skip the number of duplicates. So for example, if 2 rows are rank 1, the next row will be rank 3, introducing a gap in the sequence. So we have the syntax for the rank function as select. You specify the columns to which you want to retrieve your data. In our own case here, we are retrieving column 1 and 2. You use the rank function keyword. Then we use the over, and then we also open our bracket, and then we use the partition by. We specify the column to which we want to partition our data. In our own instance here is partition underscore column, and then you order it by a column to which you want your data for. So in our own case, we use sort underscore column, and then you specify your table to which your data is coming from. In our own case here, we have table underscore name. So we have an image to illustrate the rank function. So we are retrieving the employee ID, the employee department, and the employee salary. Then we are using the rank function, and then we were partitioning our data by the employee department. Then we're also ordering it by our employee salary. Then we assign the sequence number to all of this from our employees table. So our resulting table, we have HR department, which has 3 employees in that department, employee ID 108, 109, and 110. All of these 3 belong to the HR department. So it introduces a gap where we have employee ID 108 ends 50,000. It assigns a sequence number of 1 to it, but employee ID 109 and 110 they earn the same salary, so it assigned the same sequence ID number to them, and then it introduced a gap between the two of them. So you can see we have 2 2. Next, we have logistics department. Also, they have 3 employees in that department. We have 113, 114, and 115. 113 and 114 earns the same salary, which is 35,000.
Now it assign 1 and 1 to them, then it skip the next number just like we said. It normally skip the next number if they have the same value. So it skip and then it assign the third employee, which is 115, that ends with 45,000. It assign a sequence ID of 3 to 8. We have an example to illustrate how the ranking function works. We are to rank employees by salary within each department. So let me go back to my ID so that we can be able to do that. Back to my ID. We are to rank, let me comment this. We are to rank employees by salary within each department. So for us to rank our employee salary between each department, let's retrieve our columns. So we want to retrieve our employee name. Next is for us to get our department ID, department underscore ID. Next is for us to get the salary. Then we use the rank function keyword. So we use it as rank. We use the over and then we open bracket. We want to partition it by. So we want to partition by our department ID, department underscore ID, and then we want to order it by our salary. So we want to order by our salary. So we want the ordering should be in descending form. Then we close this. So let's assign this as ranking. Next is for us to specify the table to which our data is coming from. It's coming from our employees. So with this, we can be able to rank employees' salary within each department. So let me highlight this and run so that we can be able to see. Highlight this and run. So we have seen John Ugo, which doesn't belong to any department, and 60,000 naira. It's assigned a ranking of 1. We have Agape Sam, which belongs to 101 department. It's assigned a ranking of also 1 because he's the only person in that department. We have John Joseph, which belongs to 102 department, which earns 300,000 naira. It assigned a ranking of 1. We have Alice Udo, who also belongs to the same department as John Joseph, and then earns a salary of 100,000 naira. So it introduced a gap between the two of them because they don't earn the same salary. That's why we can see 1 and 2. If I paraventure they were earning the same salary, we have seen 1 and 1, but they are not earning the same salary. So that's where it has introduced the gap. And also the remaining employees, all of them, they are the only person in the department. So that's where we can see their ranking also as 1 and 1, 1, 1, 1. So this is basically how we implement the rank function. This will now lead us to look at the lit and the lack function. They allow users to access data from preceding or following rows without the need for self-join or subqueries, making them invaluable for analyzing sequential or time series data. The lag function is used to retrieve the value from the row that precedes the current row. This can be particularly useful when comparing a value to the previous one, such as comparing current salaries to the previous day's sales. Next, the lead function, on the other hand, is used to retrieve the data from a row that succeeds the current row. This is helpful when you want to compare a value to a future one, like forecasting future sales based on current trends. We have an example to illustrate this. We have 3 columns: seller name, seller value, and previous sale value. So we have Steve, which sale value was 7,000. Previous value is null because there is no any amount before Steve amount. Next, we have Alice, which the sale value is 12,000. It has a 7,000 previous value coming from our sale value from Steve. Next we have Millie. Millie has a sale value of 2,000, 25,000, and then the previous sale value is 12,000, which is coming from Alice. We have an example to illustrate the lead and the lag function. How does an employee's salaries or performance score compare to the previous and their next evaluations within the department? So let me go back to my ID so that we can be able to implement this. Back to our ID. Let me close our resulting query. Then let me come down. So first of all, we need to introduce another column to our database. So let's use the alter keyword. So alter table. We want to alter our employees table. Next is for us to add the performance score column. So we need to add performance underscore score, which has a data type of integer. So with this, we can be able to add a column to our data. So let's highlight this and run. So we have added our performance score column to our data. Next is for us to update our employees. So let me bring it down here a bit. So let's update our employees table. Sorry, employees table. Then we set our data. So we want to set our performance score. We want to set the data using the case statement. So we use the case statement where we want to use the employee ID, employee underscore ID. When, let me bring it here. So when our employee ID is 1001, we want to assign 75 to it. Next, we use when our employee ID is 102, then we want to assign the performance score value of 88. Next, when our employee ID is 1003, then we want to assign the performance score of 90. When our employee ID is 1004, then we want to assign the performance score of 95. Next, when our employer ID is 1005, then we want to assign 87 to our performance score. When performance ID is 1006, then we want to assign the performance score of 78. And then lastly, when our employer ID is 108, then we want to assign 56 to our performance score. So we end our case statement over here. Then we use the where clause to specify employee ID, and then we pass in those IDs. So we have 1001, we have 1002, we have 1003, we have 1004, we have 1005, we have 1006, we have 1008. So with this, we can be able to add our records into our performance score. So before going on this, let me check our IDs so that let me be sure of the IDs we are entering our data. So let me select all from my employees. So let me be sure about these IDs. Then run. So I have 100001. Yes. So I can delete this and I can close this. So let me go ahead and insert my data. So let me highlight this and then run this. So we have successfully added our records into our performance score column. So next is for us to get the employee salary or performance score compared to their previous salary. So let me comment this. So we have to how does an employee's salary or performance score compared to their previous and next evaluations within their department in their department. So for us to do that, let's get our columns to which we want. So we use our select text statement to retrieve our data. So we want to get the employee name. Next is for us, let me bring this down. Let me bring this down and then let me shift it like this. Next is for us to get our department ID. Let's get our department underscore ID. Next is, let me again put the comma here. Next is for me to get the salary. So we need to get the salary. Next is for me to get the performance score. That's performance score. Next is for me to use my lag function. So open bracket dot salary, then I close my bracket. I didn't add the comma here. So I use my over keyword. Then I open my bracket and want to partition my data from my department ID. I want to partition it by my department underscore ID. Next, I want to order it by the salary, salary. Then I want it to be in descending form. Close this. So let's alias this as our previous underscore salary. Next is for me to use my lead function to get my next salary. So I retrieve my data from my salary column. Then use the over keyword. I open my bracket. I want to partition my data. I want to partition it by the department ID. So sorry, I didn't use the E here because I want to get my data from my department ID from my employees table. Next underscore ID. And then I didn't add order by here. I want to order it by my salary, which is which is coming from my salary from my department in my employees table. I also want to get in descending order. I want to alias it as my next salary, next underscore salary. Next is for me to, I didn't add a comma here, Add a comma here. Next is for me to get my performance score. So I want to get my previous performance score. I will use the lag function. Then I'll specify the column to which I want my lag function to perform on. So I want to get it on my performance score. And that's cool. Then I want it. I will use the over keywords. I want to partition it by. I want to partition by the department ID. It is e dot department underscore ID. And then I want to order it by the performance score. So I want to order by the performance score. This e dot performance underscore score. I want to get it in descending form also. And then close brackets. So I want to alias this as our previous score. So this is our previous score. Yes. Next is for me to get my next score using the I didn't use partition by here. So next is for me to get my future score using the lead function. So using the lead function, I want to get my performance score underscore score. I'll use the over keyword. Then I want to partition it by I want to partition it by my department ID. Then I want to also order it by my performance score. And then I also want to get it in descending form. And then I'll alias this to as my next underscore. S here should be capital. And then I'll specify the table to which our data is coming from. So it's coming from our employees table E. So with this, we can be able to use the lag and the lead functions to obtain the next salary, the previous salary, the next score, and the previous performance score. So let's run this so that we can be able to see how this plays out. So highlight this and run. So you can be able to see John Ugo, which doesn't belong to any department, has earned 60,000 naira. His performance score is 56. So it doesn't have the previous and the next salary. So also it doesn't have the previous and the next score. Simply, the reason is that simply because it's the only person existing in that department. So we have Alice Udo and John Joseph. These are two people that belong to the same department. So we have the performance score of Alice is 88, which her previous salary is 300,000. And then we have John Joseph, which has a performance score of 78. His next salary is going to be 100,000, while the Alice Udo next performance score will be 78, and then John Joseph previous performance score will be 88. So this is how we use the lead and the lag function.
We have successfully come to the end of today's class. At the end, you should be able to know how to use complex join to analyze data from multiple related tables across various scenarios. You should be able to leverage subqueries for advanced data filtering, and then you should be able to know how to use the union, the intersect, and except for effective data comparison across multiple data sets. And then you should be able to use the row number and rank functions in order to identify and rank rows within data sets effectively. And then lastly, you should be able to know how to use the list and the rank function in order for you to analyze time series and sequential data effectively. So we also have our assignment for the week. So our assignment for the week, kindly find attached table. So the table is being attached to this document, and answer the following questions. Write a query to list all customers and their transaction details. Ensure customers without transaction and transaction without matching customers are included. Identify customers who have the highest total transaction amount using a subquery, and then write a query to combine the list of customers from Lagos and Edo using union excluding duplicates, and then assign a rank to each transaction based on the transaction amount in descending order. Additionally, use lead and lag to display the next and previous transactions amount for each transaction order by the date. So basically, this is your assignment for the week. I wish you the very best. See you in the next class.
Thank you for being an active learner in today's session. Keep pushing your boundaries. I look forward to see your progress in the next class. See you soon. Bye.